None other than Gunwell Coldwin gathered a party of loyal companions to create a number of different tomes. Those tomes should go down in history as paged out. The call for papers for the first issue is still going on, until the pagedout team has received 50 articles. The two basic ideas of the magazine are: article size is limited to at most 1 page, and the author alone is responsible for the layout. Monday the 10th of June, a new example article for the Pagedout online magazine has been published. It contains a reverse engineering challenge with 2 levels of difficulty. Resolvers of the harder challenge will take part in a raffle. In order to test the challenge, I started a race with 4 well-known YouTubers. Let's introduce them. Murmus CTF, zanidd, John Hammond, and, of course, Bogan from Gadget Overflow. What? Why? But he said... Okay, let's take the other overflow guy. All the racers finished reading the article. zanidd takes a look at the Gatekeeper 2 strings. John uses the command line to get the repo. And checks the element with the hash in the readme. Checking the file type of Gatekeeper 2, changes the mode bits from executable and executes it. Live does the same, chmod and executes Gatekeeper 2. John tries to execute with John wins. zanidd supposes Snow White as username. Without skirmishing, Murmus starts G-Hydra. Live checks the file type as well. We also see G-Hydra in action at John's screen. Live examines the Python patch from the task more closely, and zanidd executes Gatekeeper 2 without credentials. Live downloads the Gatekeeper repo from GitHub. zanidd executes the binary with credentials Snow White. John's Greater Hydra is ready to work. Live executes Gatekeeper without credentials. John checks the hard-coded strings. Murmus G-Hydra is also ready to use. And he checks function main. LiveOverflow would like to work with Greater Hydra also, but he does not have it on his computer and downloads it directly from gdrasre.org. John discovered string compare PewPalm 2 Snow White.
If it's equal to Snow White.
Murmus discovered this almost at the same time as John. Live wants to view the Gatekeeper binary as hexdump, but has not installed it. This will cost him time again. John renames the variables of the decompiled code, and Live does not yet have access to hexdump and is busy finding the right package name. zanidd outputs the disassembly with object dump.
which eventually needs to stir compare to...
Murmus finds the second string comparison. John takes a closer look at the first string comparison. zanidd writes the disassembly in a separate file, while John executes Gatekeeper 2 with Snow White anything, and zanidd views the disassembly with Vim. Live compares both hex representations of the binaries with Vim div.
So we malloc svars. Svars is the length of the second parameter. We then stir compare the destination, or stir copy that into destination. Okay, so we put it on the heap. We're then going to get the stir len of that again, which we already got, but I guess we're going to get it again.
Live discovers the change from one warm to Snow White in the two binaries.
And we have a string compare.
zanidd discovers the jump to string compare from glibc. John's Gatekeeper failed and he notes it almost untouched, and keeps trying to understand the code. Meanwhile, Murmus adjusts the variable names. John tries out to write shift operator in Python. Live is studying the pagedout article and marking the solution of the first Gatekeeper version. John and Murmus continue to try to read and understand the decompiled code. Live now also has the possibility to use Greater Hydra. Let's just listen to what Murmus thinks so.
So we go to the end. So the first time through this loop, I is 0. We're going to get length. Length would put us over the end, -1. So we'll get the last character. And we set that there. Then we take the length again. So we're just swapping every other character. That's what that looks like.
Murmus has given a pretty good summary. Live's G-Hydra is ready to rock.
Okay, so how does this console work? I've never actually tried to use it. Oh, let's give this a try real quick.
Murmus tried to use the embedded console, but stopped and instead wrote a Python script. Live discovers the string comparison with one warm in Gatekeeper. John copies the decompiled C-like code into a separate file, and that seems to be a head-to-head race with Murmus. Live tries to run Gatekeeper and searches for the password. zanidd uses GDB to debug Gatekeeper 2 and sets a break at main. Live has determined the encoded password with string and inverts it with a Python array operation. Now he executes Gatekeeper with the found credentials. Murmus prepares a Python loop. I runs from 0 to the length of goal for every even value. Goal is the string of the encoded password. He changes his mind and it should be an array of single characters. John determines the number of characters of the encoded password, and Murmus tests his script.
empty separator.
Unfortunately, the split function cannot be used in this way. Oh nice, he bypasses the problem with a simple Python list comprehension. And the test worked.
That looks good to me. Temp is equal to goal I.
John starts transpiling to Python, and Live is currently checking the code of Gatekeeper 2 in GHydra. zanidd views the assembly code of the main function. John has transpiled the first line in Python. Live tries to understand the decompiled Gatekeeper code and to rename variables. Murmus has almost finished the transpiled algorithm but still has a little bug in a variable name. However, now he has a first result as an array of characters and again generates a single string from it. Impressing, he has not run the binary yet, one single time.
Okay. Crackem Arcors. So...
and prepares it shortly. And tests it without credentials.
Oh, that's cute. Cool. So we said we needed our username to be Snow White. Wanted this to be Pie.
Live renames the variables of Gatekeeper. John has almost finished to transpile his Python code. Live copies the extracted code as text into a separate file. And now also renames the variable names in Gatekeeper 2.
Denied? Bad password.
Murmus' attempt looked promising but failed nevertheless. And he looks again at the output of his script.
Interesting.
Tries it a second time. He does not seem to trust the interface from console to Python output and passes the password manually. John keeps working on his script but does not seem to be getting on well. Live copies the decompiled Gatekeeper 2 code with the name changes and places it right to the Gatekeeper code. Checks the difference manually and change another variable name to X. John has transpiled the last snippet. And documents the decisive height. Live determines the file differences automatically. Murmus runs GDB Gatekeeper without credentials. He sets breakpoint 1 in function string compare. And runs Gatekeeper 2 with the found credentials. John's script does not change the input value. Murmus sets a second breakpoint at main, turns off the first at string compare, continues executing the code, turns it back on at string compare and continues executing the code. Amazing speed. Checks now the parameters in RVI and RSI. In the first string compare and continue executing. And checks now the parameters of the second string compare.
Ooh. I messed it up. Because I kept going.
Live has started to decode the encoded password manually, while Murmus fixes his mistake. Live, so far rather inconspicuous, he is now almost on par with Murmus. Can Live catch up to him? Murmus executes with his credentials.
Right. So we braille out if it's passline over 2, and I went all the way through, so I swapped everything as opposed to just swapping the right thing.
And there is the victory. Congratulations to Murmus' excellent solution. Live is also near a breakthrough and has decoded the password. John's script does not mutate the input, and now he figured out why. He adjusts the termination condition of if. Live gets the username from the decompiled code and executes Gatekeeper 2 with the found credentials. John tries to compare the script output from the input, but made it unnecessarily difficult with his selection. And John notes what he has found. Let's fast forward a bit. John seems to have developed a sufficient understanding of the algorithm. Live's attempt is still running, and he therefore tries to continue to understand the decompiled code. Marks verify animation and becomes aware of concat44. John tries to manually reconstruct the input from the script output. While Live takes a closer look at the function verify animation. Now he realizes that his attempt was unsuccessful. John finishes his reconstruction. And figures out that his input only contains 15 characters, therefore adds a column. Fast forward a bit. John uses the output as an input and finds that the function is his own inverse. So he uses the encoded password as input and seems visibly pleased with the output. He executes Gatekeeper 2 with his found credentials. And thus climbs to second place. Congratulations, John. Live tries to debug Gatekeeper 2 with his found credentials. Fast forward a bit. Live recognizes that GDB is not pointing to the second string compare but executes a jump depending on RIP and sets the breakpoint there. Fast forward a bit. After he could extract no further information analyzing the code or debugging the binary, he tries to reconstruct the password manually again. Fast forward a bit, and this time comes to a slightly different result. Let's fast forward a little bit more. Congratulations to third place. Unfortunately, the approach was too error prone.
I'm sorry I couldn't solve it, but as said at the beginning, reverse engineering isn't my strong suit, especially if it's Intel assembly, which I have no idea.
Thank you very much to the 4 races. Murmus has delivered a sovereign result. This requires a lot of experience and knowledge. John opted for automation right from the start and therefore was able to finish the task before Live. Live has thought through the problem theoretically and was convinced that this simple algorithm is easy to invert manually. This did not work out and was ultimately only enough for 3rd place. In my opinion, zanidd has also done well. I have always noticed that he has a remarkable intuition and his assumptions are regularly correct. He simply lacked experience or knowledge. In this short time he tried to close his gaps as best as possible.
Well, thanks to Andre. This was pretty cool to work through. I'm a little ashamed that I still haven't figured out what on earth this barcode is, and it's gonna bug the crap out of me.